Hi and welcome to video some number. I've just bought a new microphone. I'm not 100% sure it's going to work all that well, so here goes. Question 5, as requested by one of you, to do with integrating a function of cost in terms of the number of TVs built by a manufacturer. So first statement is the marginal cost of producing plasma TVs in a factory is given by dCdn equals 20n. dCdn equals 20n. N is the number produced in a day, and C is the cost of producing this number. It costs $20,000 to keep the factory open for a day. So at N equals 0, we make no TVs. The cost is $20,000. Worth keeping that in mind. The manufacturer's price for each TV is $1,800, and that will come in handy later on. Find an expression for the cost of producing N TVs and the profit made on N TVs. So first of all, we need to integrate both sides. And we're going to integrate both sides with respect to N, as this will take us back to a function for just cost. Now notice first of all, I'm going to go through the algebraic methodology behind this, but it isn't necessary that you show all this working. You can now just simply write down C. But you'll notice here that the dn's cancel out, leaving us the integral of 1 dc. And on this side, it's equal to 10n squared plus little c. Notice the difference between big C, cost, and little c, constant. And if I integrate 1 dc, that gives me c equals 10n squared plus little c. I know that at n equals 0, c equals 20,000. And substituting that in, that gives me little c. The constant is also equal to 20,000. Which means that the cost is equal to 10n squared plus 20,000. That is the cost of making n TVs. So therefore the profit will be the sales, which is $1,800 times the number of TVs, plus the cost, minus the cost, which will be 1,800n minus 10n squared minus 20,000. And that is the profit overall. So now we seem to have a function, and you're being asked to find an expression for the cost and profit, which we've now done in terms of n. Using graphics calculator, part B, to find the number of TVs the factory should make each day to get the biggest profit. So for part B, I'm not going to use a graphics calculator. If you did use a graphics calculator, you would come out with a function that is clearly a quadratic. P is a quadratic. It would look like this, and you would find your maximum point there, representing n, the number of TVs, and P, the actual profit for making that number of TVs, would be your coordinate there. But we're not interested in finding that on a graphics calculator now, because I'm sure that you can all do it. Instead, I'm going to show you how to do it algebraically. P equals 1,800 n minus 10 n squared minus 20,000. To find a maximum, we derive, and then we let it equal 0. 1,800 minus 20n is what we get when we derive it. Let dp dn equals 0, and we get 1,800 minus 20n equals 0. 1,800 equals 20n, and n equals 90. So 90 units, 90 TVs will give us our maximum profit. We are assuming at the moment it's a maximum, and you should always do a second test. The second derivative test will do fine. So d squared p dn squared, which deriving again gives us negative 20, which is always negative, and therefore represents a maximum. Notice the second derivative represents the gradient of the gradient, and as it's always negative, it's implying that the gradient is always decreasing. The gradient of the gradient is always decreasing, and you can see here that there's the gradient, it's quite big. I'm looking at my graph at the moment. Then it gets a bit smaller, then it gets a bit smaller again, gets a bit smaller again, so on and so on. So our answer is that 90 TVs will be sufficient to get our maximum profit. Go back to the question, check to see if it asks for the maximum profit. It doesn't, it just asks for the number of TVs. So we've finished the question. If it did ask for the maximum profit, I would simply now substitute in that 90 into my profit formula. And that's the end of the question.